So sorry about the way that video cut off, but from 0 to 144 minutes, that gives us a reasonable domain for the amount of time that could have happened in this problem. And this is a little bit unfair for them to start with this problem. It's kind of difficult to actually figure that out. So maybe if you went back to another one, the domain would be more clear. So make sure you're hitting me up with questions to walk through these. Now the range would be more of the output part of this, and that would be how far she travels. And so she went 0 minutes, she would travel 0 miles. But if she traveled all that, 144 minutes, that gives us the 36 that we really knew from the beginning. So that would be the range. So 0 to 36 miles. Now I could abbreviate that MI if I wanted, but I'm probably writing miles out because it's just about as much time. The next part says, draw a graph that shows the relationship. And like the other ones, there's no real need to have anything in the negative area. So I'm drawing a graph here, arrows on the opposite sides, turning my page and using a ruler to make this neat enough, but I'm also not spending a ton of time on it to where I'm ending up wasting time. When I look at my domain, which is really the x-axis and its inputs that are reasonable, I'm going to label x, and I'm going to tell it that it's in time, so MINS here. And then my y-axis is going to be distance, so I'm writing DISTANCE, and then in parentheses after that I'll put MI. I would abbreviate here. So the minutes that are traveled go all the way up to 144. So I'm going to make a stop here, and I think, well, where's a good place to round that up to? I think 150 is nice. So I'll write 150. And the nice thing about choosing 150 is that I'm not going to go exactly halfway to 75, but I would count up by 50s, making larger tick marks for those bigger stops along the way. And then I can either do 1, 2, 3, 4, or just be like, well, that's going to be 25, 75, and 125. On my y-axis, I could stop at 40, and that would be just fine. Or I could be like, well, 50 maybe. But I think because I got these lines here and the way my paper's working out, I'm thinking 10, 20, 30, 40 is going to be nice. And then I could 50 up here. I'll go ahead and I'll label that 50. So, if I feel comfortable that this relationship is direct, I could really just start at 0, 0, and then go all the way to about 144. I'm doing that in red because that's really just my eyesight. That's what I'm tracing up with my eyes. And then I'm going up to 36, a little bit barely above halfway. And then where those would mostly run into each other would give me that second point that I would need. And with that in place, I could just grab a ruler and draw a straight line through both of those. And that line would represent the graph of this function. If this were a problem like the earrings one or something different, I would go ahead and be more specifically detailed with my coordinates. But I think that because I'm dealing with a more complicated function here, I'm finding that maybe I don't want to have to pull out a calculator and do all that extra work because it just doesn't really get used later on. Meaning we're not making big picture decisions with this. If I had a graph that ended up looking like this, where my x was here and y there, and instead of having connected points, I just had random ordered pairs, this would be discrete. It's kind of like a counting problem. Maybe if I sold, this for that much, that's where it would run. But nothing's connected. Like I wouldn't have like halves. That's supposed to be a fraction. Sorry about the handwriting. That's supposed to be like halfway. I wouldn't have decimals and things like that. So those counting type deals are discrete. While something that would be continuous would be measured by a straight line. Or all different continued points. There's no real jumps. So when I look at this line, it's definitely a straight path, so I'm going to say that this is continuous. Now, unlike in a language arts class where I'm restating the subject and all that kind of stuff, I'm just saying continuous, comma, all points are connected. And I want you to go to your textbook or maybe look online for definitions for discrete and continuous, because if you're not sure that you'll remember this for a quiz or a test, it's up to you to make a vocab card out of that. And you'll find those definitions clearly within the 1.9 section, or you can go to the index of your book and hunt down where they show up. So here's 1.9, functions and graph, a bunch of problems for this. Make sure that you are using a ruler to be neat and doing good planning of where your tick marks should be. And just to remind you of what I mean by tick marks, is if I have an x-axis that goes all the way up from 0 to 10, 5 and 10 would be larger stops along the way, and these increments would be shown smaller. So I want smart planning of where to start, and then I want to see larger tick marks for more important steps, and then the smaller for the other ones. But there's really no reason to label all of these, 6, 7, 8, 9. So, as with many things I like to point out, be a little bit flexible and decide when it's good to be crazy detailed, and then just a reasonable amount of accurate.